What's up? It's Dr. Taylor Krick, host of the Autoimmune Doc podcast, and it's been a while since I made a video reviewing some studies that I love making videos reviewing studies that I think are applicable to people in real-world settings. So this is a really good one. It's about COVID, which, obviously right now it's 2022. This came out in August of 2021. But this is just a really good paper about some of the mechanisms of COVID. I think that everybody's always trying to understand what COVID maybe has done to them, or what's going on as we continue to learn more and more about it. This is about the effects that COVID has on gut health. So very, very cool. I've seen some really cool, interesting changes with gut health with COVID. I've seen a lot of really interesting things with COVID long haulers and COVID-induced autoimmunity, and certainly some COVID, intervention, side effects and things like that too. So this is interesting. It's from the World Journal of Gastroenterology. So let's go through it. So first off, it's 22 pages. So I'm not going to read it all, of course, but it has some great pictures. So if you've seen any of the other studies that I review on this channel, I like good studies, but I also like studies that have good pictures because I think they kind of illustrate what the overall take-home message is from the study to lay people and to the general public. So the therapeutic implications of COVID dysregulation of the gut-brain-lung axis. So first, let's look at the abstract here and just read through this abstract. So it says, COVID, blah, blah, blah. It says many individuals develop pneumonia, acute respiratory distress syndrome, shock, multi-organ dysfunction. In addition to these primarily respiratory symptoms, COVID can also infiltrate the central nervous system, which may damage the blood-brain barrier and the neuron's synapses, result in inflammation and neurodegeneration in the brainstem, can further prevent efferent signaling, so that's motor signaling to the cranial nerves, leading to loss of anti-inflammatory signaling and normal respiratory and gastrointestinal functions. We're going to talk about that right now. They're talking about brainstem signaling for the vagus nerve, big topic of mine. Additionally, SARS can infect gut cells, resulting in gut damage, followed by dysbiosis, so imbalance of the probiotics of good and bad bacteria of the gut, and translocation of bacteria and their byproducts like LPS across the damaged gut lining. So it's saying it leads to leaky gut and translocation or inflammation from endotoxemia from LPS. As a result, this exacerbates the pro-inflammatory response both locally in the gut and systemically, resulting in impaired clinical outcomes. Recent evidence has highlighted the complex interactions that mutually modulate respiratory, neurological, and GI function. In this paper, in this review, we discuss the ways that these all, go together. So, very, very interesting. So let's go through here. So intro, just about a lot about COVID, that I'm not going to talk about. I think we all have heard about it. The immune architecture of a healthy gut. So this is a really cool article, and if you want to, just ask me. The full text is available for this. But yeah, it's really interesting. It says critical genera of the microbiome also ferment dietary fiber into short-chain fatty acids. That's one of the major takeaways of this paper, and one of the major takeaways of microbiome and gastroenterology and immunology research and gut-brain and neurological research, and really about any research today, is about short-chain fatty acids, about postbiotics. So it says the short-chain fatty acids support gut immune responses by sustaining the balance of Treg cells and activated T cells. Regulatory T cells dampen autoimmunity, and activated T cells attack things like viruses and attack self-tissue in autoimmunity. The released short-chain fatty acids, such as butyrate, facilitate the production of retinoic acid, of vitamin A, which in turn aids in the generation of FOXP3 Treg cells, regulatory T cells, sampling of antigen across the gut lumen. Increased frequencies of Treg cells maintain a basal anti-inflammatory state of the gut. So these Treg cells are really, really important to maintain tolerance of the gut. It says right here something about TGF-beta, which is an important lab marker that I'll see skyrocket in long COVID. It promotes increased frequencies of Tregs that are crucial for immunological suppression and induction of mucosal tolerance. Then this next section goes on to talk about actual COVID infection of the gut and how COVID can actually infect gut cells. Not going to read it. Then it goes on to talk about gut inflammation. An optimal balance between regulatory T cells and Th17 cells is maintained within a healthy gut. When that teeter-totter gets flipped, we get more Th17, we get more inflammation. So it goes on to talk about IBD and Crohn's and ACE2 expression, so different things with COVID and increased inflammatory. So cytokines like IL-6 and IL-17 that select for increased frequency of Th17 T cells and susceptibility to inflammatory conditions like IBD. Several studies talk about the co-occurrence of IBD and COVID, blah, blah, blah. It keeps talking about biologics, how several biologics may actually worsen COVID outcomes. Corticosteroids may worsen COVID outcomes, may exacerbate already frequent clotting that already occurs. And they go through and talk about some of these medications. They also talk about some of the vagus nerve stimulation. So I'll talk about that in a second. But yeah, this is all very, very interesting. We're still getting to these pictures, so don't worry, they are coming if you're getting bored. It says, furthermore, earlier in the pandemic, low circulating vitamin D became a known risk factor for COVID. In higher cytokines, including IL-6, it's talking about how vitamin D is encouraged to decrease that inflammatory IL-17, that Th17, tissue-damaging autoimmune inflammation. SARS-CoV infection results in dysbiosis in the gut. So, that's pretty self-explanatory, but COVID leads to dysbiosis. It changes the makeup of the microbiome. So let's check out this first picture here. It says, here's gut homeostasis. You've got good things. You've got, good endothelium, which is the blood flow. You've got good epithelium, which is the gut lining. They're tight junctions. Over here is more, you get opportunistic fungi. So opportunistic fungal overgrowth, a really, really important part of some that I see with a lot of COVID-induced microbiome changes. You get some reduced beneficial bacteria compared to over here, and you get more detrimental bacteria. You get more opportunistic bacteria and dysbiotic bacteria over here. So, analysis of the fungal microbiome revealed significant proportions of opportunistic fungal pathogens such as Candida, Aspergillus were enriched in the gut microbiome of COVID hospitalized patients. Aspergillus in the respiratory tract with COVID. So I think that's really, really interesting. It says in such cases, antifungals should be considered. Again, I see that very, very commonly. COVID infection affects the homeostasis of the gut-lung axis. Not going to read through that one too much. There are some interesting things down here about short-chain fats and about vagus nerve stimulation. So it says the vagus nerve innervates the lungs' distal airways upon stimulation. Nerve endings release acetylcholine, which functions to regulate lung infection. So there's a lot in this paper about acetylcholine and acetylcholine receptors. And now acetylcholine receptors and decreased what's called cholinergic anti-inflammatory pathway are really, really a proposed mechanism for this. So I'm going to try to find this part about vagus nerve stimulation. I don't think I've missed it yet. In addition, the host immune system's direct mutual interaction in the gut-brain-lung axis, commensal and pathogenic bacteria in the gut microbiome can also influence COVID-19 pathogenesis. Short-chain fatty acids maintain and reinforce epithelial integrity, decrease inflammation in the GI tract, and fortify the tight junction permeability. Increase gastrointestinal permeability, increased leaky gut, was associated with clinical worsening. Short-chain fats influence the inflammatory state of the host epithelial cells. Basically, they modulate inflammation. They're anti-inflammatory, modulate the autoimmune response that's really triggered off oftentimes with coronavirus. This picture showing the vagus nerve signaling pathways with acetylcholine. Acetylcholine is the primary neurotransmitter of the vagus nerve. So you see here we just show that the brain, it affects the heart, affects the lungs, decreases inflammatory transcription, decreases pro-inflammatory cytokines, inhibits Th17, inhibits tissue-damaging autoimmune inflammation, promotes kidney function, promotes decreased IL-6 from the liver. So there's some really, really interesting things in here about vagus nerve stimulation and about the vagus nerve. Here's the things about the gut-brain axis. Here's the things about nicotine receptors. So I'm not going to go into this too much, but it's talking about how these nicotinic acetylcholine receptors are possible therapeutic targets to limit the damage in the gut brain. It says vagus nerve stimulation delivers electrical impulses to the left vagus nerve via a small device that's implanted beneath the collarbone. But it says, however, less invasive transcutaneous auricular vagus nerve stimulation is being developed. Although more clinical, extensive clinical studies are ongoing, case studies have indicated that it can reduce plasma IL-6 levels. So vagus nerve stimulation can reduce IL-6 release from Kupffer cells in the liver through the cholinergic anti-inflammatory pathway when using these devices. So all these things have been proposed to reduce systemic inflammation. So there's some interesting things in here about vagus nerve stimulation. Then here's the last picture, and this is just shown over here on the healthy side. If you've got a healthy gut and you've got healthy gut-brain connection, you're going to have good commensal bacteria, and it outcompetes pathogens. So your good bacteria actually outcompete the bad ones. You've got anti-inflammatory environment that's favored, and you've got a lot of short-chain fatty acid release, and that is driving good brain function, and then good brain function is driving good gut function. This goes both ways, and when you have this, you also have healthy lungs. Whereas over here, you start to see this diseased gut, where you have more pathogens, you have more microbial translocation, you have more SIBO, you have more LPS, you have more leaky gut, you have more damaged gut barrier, you have more loss of tolerance. So you have more food sensitivities, loss of oral tolerance, you have more GI inflammation, reduced short-chain fatty acids. It leads to a diseased brain. You get more activated microglia, you get more reduced blood-brain barrier, reactive microglia, and defective neurogenesis. You don't make good new neurons as well. And this goes both ways, and then you get more of a diseased lung state, and you get more COVID infection that's promoted. So we're talking about the importance of the gut-brain connection for COVID responses, but also for therapeutic implications of this. So, let's see what this says. I don't remember this. It should be noted that in addition to a disruption to its anti-inflammatory functions, the vagus nerve may also contribute to the COVID pathology in other ways. And they're talking about alpha-synuclein aggregates accumulating. They talk about inflammatory response with other decreased motor output of other cranial nerves. So this is really quite interesting. They talk a lot about, again, vagus nerve, short-chain fats, activated microglia. Here's the last picture where they really just talk about how in malnourished populations this might need to be looked at because they could be more likely to be exposed to these things. But what I would say too, this is just my personal opinion on this, is that a lot of times in rural areas where they don't have as much industrialization, their gut microbiome and their gut-brain connections might be healthier to begin with. They don't have as much air pollution. They don't have as much toxins in their tap water, toxins in their food, heavy metals, chemicals, things like that, disrupting their microbiome, disrupting their vagus nerve. They don't have as much stress. They might be better off in some of these areas. I don't know. But what they're saying is, hey, this needs to be more well understood. So anyway, very, very cool paper, in my opinion, about gut-brain connection, gut-brain lung connection, and how it impacts that. So hope